Hello everyone, this is Keith Jackson and welcome to Jack's Math Notebook. In this video, we're going to graph quadratic functions. And then we're going to take a look at the discriminant to justify whether the graph is going to have two real solutions, one real solution, or no real solutions, right? And if you recall from a previous video, if the discriminant shows b squared minus 4ac is greater than 0, we're going to have two real solutions. If the discriminant shows b squared minus 4ac is equal to 0, we're going to have one real solution. And if the discriminant shows b squared minus 4ac is less than 0, we're going to have no solutions. And we're going to show you what's going to happen with each one of these examples, beginning with example 1, in which we have x squared plus 2x minus 3 is equal to 0. And in this case, to graph this function, we're just going to simply use the axis of symmetry formula, which is read like this. X is equal to a negative b divided by 2a. And we're just going to plug those numbers in there to find the axis of symmetry. And when we do that, we have x is equal to a negative 2 because we're going to plug this 2 here. We're going to attach that negative to it, divided by 2 times 1 because this is 1 right over here. And so when we do that, we get this. It will equal to a negative 2 divided by 2, which will give us a negative 1. And we have x is equal to a negative 1, which kind of serves as our h value right here because we're going to plug that negative 1 back into this function right here. So wherever we see an x, we're just going to put a negative 1 in its place. And so now we have y is equal to a negative 1 squared plus 2 times a negative 1 minus 3. And when we do that, we have y is equal to 1 minus 2 minus 3, which really equals to 1 minus 5, which will equal to a negative 4 that you see right here. And so as you can see, our axis of symmetry is going to be at negative 1 for our x value and a negative 4 for our y value. And guess what? Now we have our axis of symmetry. And because 1 is the leading coefficient in this formula, or I should say in this equation, all we have to do is just go over 1 up 1 and then over 1 up 3, because our parabola is going to look just like that, just as long as we have 1 as our coefficient for our x squared term, you see right there. And so as you can see, we have two real solutions, one real solution at negative 3 and the other real solution at 1. And as you can see, that must be the case in which b squared minus 4ac inside the discriminant is greater than 0. Let's go on to big example 2, in which we have x squared minus 4x plus 4 is equal to 0, using our axis of symmetry formula, which we have x is equal to a negative b divided by 2a. And we're going to plug those numbers in right here, and we have x is equal to a negative 4 divided by 2 times 1, which really means that we have, because it's double negative, gives us a positive. So we have a 4 divided by 2, which will give us 2. And all we have to do is plug in 2 wherever we see x. All right, so we have y is equal to 2 squared minus 4 times 2 plus 4. And here's what's going to happen. We got y is equal to 4 minus 8 plus 4. And that's actually going to equal 0. And so now we have our point, right? Our axis of symmetry at 2, 0 right there. As you can see right there, it is only touching the x-axis at one point, which is 2. And so our one solution is 2 right here. All right, so let's move on to our third and final example, in which we have x squared minus 2x plus 2 is equal to 0. Plugging these numbers into our axis of symmetry formula, we're going to get x is equal to a negative 2 divided by 2 over 1, which will give us a 2 divided by 2, which will give us 1. And we're going to plug that 1 right back into where we see the x's, right? We're going to replace that 1 where x was. And so we have y is equal to 1 squared minus 2 times 1 plus 2. And so here's what we have. We have a 1 minus 2 plus 2, which would give us 1. All right, and so our ordered pair right here, or I should say where our axis of symmetry is going to be located, is at 1, 1. And as you can see right here, it does not intersect the x-axis, right? It doesn't crisscross the x-axis, and so we don't have any real solutions here. All right. Yeah, I've been given a lot of information. I wouldn't blame you if you need to pause the video to take a look at these 3 big examples, or replay this video as many times you need to gain a deeper understanding of this concept. But in the meantime, please comment, share, like, and subscribe to Jack's Math Notebook for more content. Thank you, and goodbye.